Welcome to the Stormsurf Video Surf Forecast for the week starting Sunday, July 10th. Looking at significant wave heights for the South Pacific Ocean, we see not a whole lot going on. Small area, 26-foot seas, almost in the Southeast Pacific, aimed a little bit northeast, but these seas are just not high enough to survive the journey up into California. Certainly some swell in the 15-second period range for Chile up into Peru, but probably not a whole lot to result for the U.S. West Coast. Reviewing what's happened over the past week in the Southern Hemi, we see an area here, 28-foot seas. This is really associated with a gale here that was southeast of New Zealand the day before with up to 36-foot seas. Swell from that system has already passed Hawaii, is currently hitting California. Not big in size, pure swell. In the 1.5 at 17-second range as of right now. That swell to continue into Monday. Fade out a little bit Tuesday. But we watched this system. It kind of hung on here. We'll see if we can, there you go, right in there. Not a whole lot, but maybe a second pulse of small swell to result from this. Notice it's up at 35 south. That's well to the north, cutting off a lot of the distance needed to travel into California. Maybe a second small pulse of swell midweek, but I mean, size-wise, nothing to write home about. Now, the other system that is of interest was on Wednesday night here, pushing under New Zealand, 32-foot seas. This on, I forget what it was, about the 218-degree track to California, unshadowed, but again, not a large system, not with high seas, a long ways away, but pretty well positioned relative to Northern California. And that pushed into Thursday, you can see it here, and then faded out. That's good for another small pulse of swell, but nothing more than that. And then we'll just wind this out to current time. There we are, and you see our current state of the Southern Hemi. Next, we take a look at jet stream level winds. This is forecast data now. Current as of Sunday, 12Z. We're looking for a trough, that is a push in the jet to the north. We sort of see something trying to go on here. The jet has been pushing way down around 70 south. The ice line is about 65 for Antarctic ice, so the jet has to be north of 65 south. And with some veracity or some velocity to it, we're not seeing that as of right now. We'll roll this out. Basically a big split here in the jet, a bit of a ridge pushing south again to the ice line, if not beyond it. But then we get into about Monday sometime, and notice this, a bit of a trough trying to dig out with some winds here, about 130 knots, and that pushes north. And notice the northern stream of the jet, or the northern half of the jet, and the southern half come together, create some strong winds here, but it's really the winds pushing to the north that we're most interested in. Anyway, decent trough here on Tuesday. Now notice winds kind of fade a little bit. We're down into the 110 knot range. You really want to see about 130 knot winds pushing north or more. Still, that trough pushes east into Wednesday night, and then another pulse of energy starts working its way over Antarctic ice. Again, about 140 knot winds, but the cutoff here for Southern California is right around 117. That's barely in the window. So one could say, and there you even get a little pocket of winds right on the hairy edge of the California swell window. Certainly for Mexico, Central America, Peru, this looks supportable of a gale, maybe a little bit more, but the upper level charts don't always tell the whole picture. Also notice here, bit of a ridge building behind that into next weekend, and we'll just roll this out. The ridge continues. Notice there's sort of a cutoff trough trying to get organized way over here by New Zealand, but not with a lot of wind energy to it, and typically these cutoff sort of situations don't develop very well. Next, we go down to the surface. Surface level pressure, surface level winds. We're looking for winds pushing to the north or northeast, preferably with velocity at 40 knots or better, preferably 45 if you really want to get serious. Okay, 60 knots, but that's probably not realistic. So we have a little fetch here Sunday afternoon, supposedly, what's that, 35 knot winds. And then here is this developing trough we saw in the upper atmosphere. Small area of 55, what is that, 55 Yeah, not winds on Monday night, but let's see what happens. It quickly, notice it's falling south. You need the fetch not only to have velocity, but it needs to be tracking to the north, and the winds need to be aimed to the north, more like this area here. So watch this. It's pushing northeast and lifting a bit to the northeast. You want to get as much momentum as you can pushing to the north to get swell into the California swell window. Into Wednesday, not a whole lot of velocity, 30, 35 knots over a large area, but probably not enough to do anything. We look here, we see 40 knot winds, but notice it's all aimed right at Antarctica. Nothing will come from that relative to us. Fetch continues over into Thursday in the southeast Pacific and even into Friday. This looks like a great setup for really closer locations because you don't have really 40 knot winds or 50 knot winds, so you're going to get a lesser period swell which will decay the further it travels. So the closer to these systems you can be within about, let's say, 800 or 900 miles, the better. So certainly Chile, Peru should do quite well, and even Central America from this, and even for that matter Puerto and southern Mexico. Rolling out now, we continue, and just not a whole lot going on. So things don't look super promising on the jet stream charts or on the surface level charts. Let's go take a look at the wave models and see what effect these winds will have on the ocean surface. So here we go, significant wave height, South Pacific Ocean. We'll just sort of roll this out. And as expected, as the trough develops on Monday, we see 22, 23, 24. Notice here's higher seas, but they're all aimed off to the east, and this is that fetch that's falling to the south, and you can see it clearly there. No swell from that relative, maybe down here southern Chile. It is this area, and that's only 24, maybe 26 foot seas. There's 26 foot seas, so maybe 15-second period swell. Yeah, you get something, but not a whole lot. Another fetch, again, falling south. Here's that other fetch we saw with winds pointed right. There's the ice line, as you can see. What is that, 65? Oh, maybe even 62 to 63 right in here. Kind of varies. But we're approaching maximum ice coverage in the southern hemi, especially when you get in towards later July. Again, here we go. What's this? 22, 24, 26 foot seas. And they're finally 28, almost 30-foot seas. But notice it's in the Southern California swell window, probably not for Northern California, or very obliquely. The focus, of course, looks to be Peru. Again, seas aren't super high, though, so maybe not. But it is lifting. Look at that. Well, watch this. This is kind of interesting. This is a good example of northeast lifting, traveling fetch. That fetch, the winds in this area, will not only create seas, but as the seas radiate to the northeast, the fetch keeps blowing over and moving with the seas, imparting more energy, more period, and more size to them. And we see that here. That suggests good, long, good, maybe not size, I mean, some size for sure, but a lot of waves per set in this area right in here, if one is to believe the models this far into the future. And then we go 180 hours out, and everything goes to sleep, and that's the end of it. So, from the southern hemi, there is swell in the water, second pulse maybe midweek relative to California. Another pulse from a gale that pushed under New Zealand, probably late next weekend relative to California, and a little bit of sideband energy late in the week for Hawaii. Next option maybe is wind swell. We're looking for the standard California pressure gradient. We've not talked much about this in these videos. We do it on our written forecast. High pressure is what we're looking for here. And when it pushes ridges to the east, right along in here, you tend to get a lot of northwest winds along the coast, which of course creates wind swell. Sometimes this pressure gradient, because this is desert here, you have a lot of rising air, you have sinking air here. The difference in pressure between the two is what's called a pressure gradient. When the isobars start getting packed close together, that generates wind. Wind, of course, generates wind swell. So we see consistent 20-knot winds, but you really want a little bit more than that, and we're ignoring the obvious here for the moment. But what is supposed to happen is come about Thursday and Friday, supposed to get get 30, 35 knot winds here along Cape Mendocino. Certainly good for wind swell. And notice a bit of an eddy flow if we can, there we go. That is, so what happens is you get this kind of a low pressure thing going here, and it actually creates south winds sucking up into the low, and that creates it can be a good thing, and that helps warm local waters a bit too. And so we're into Saturday, still 30 knot north winds, reasonable conditions, and wind swell more than likely. All right, now the tropics. Remnants of Bloss, pretty much gone. Was a hurricane, 110 knot winds, I believe, on Wednesday. Again, it was taking a pretty much westerly track, most of that swell targeting Hawaii. There is maybe some small, 2 or 3 feet at 10 second, 11 second, maybe in 12 seconds. Southern California got some of that, but not very prolific, again, due to the track, whichever way the storm goes. And notice, winds are counterclockwise in low pressure in the northern hemisphere, just like you can see it here see the wind barbs. So, and if the storm's moving this way, and the winds tend to be more in the north half of the storm, that means all the swell is being generated, radiating out this way, again targeting Hawaii. Next system, Celia, developing, forecast to get reasonably strong here, tracking well towards Hawaii. We'll just run this guy out here. You can see it moving a bit north of the islands. Notice high pressure here blocking its path to the north, so it just takes the path of least resistance, pushing supposedly north of the islands on Sunday and still holding together pretty good. Certainly good for pretty decent hurricane swell for the islands if this materializes as expected. Here's another way to look at Celia. Current position, it's a minimal hurricane as of today at 18Z. Forecast to get up to about 90 knots on the 12th. That puts it right out here. That's still a good long distance from Hawaii. And then this model is probably not as optimistic as the GFS model. GFS really isn't geared for tracking hurricanes. This path is a blended path of a bunch of models, some of which are very high resolution and geared towards tracking hurricanes. So still a path north of the islands expected. This only goes out to the 15th. GFS goes out a week. This is basically a 5-day track. So again, close, in relatively close agreement to the GFS model, just strength probably not as much as what was suggested. So Hawaii would be the focus of that. Yes, it's possible to get a little sideband swell, but if you don't get these hurricanes pushing almost due north, you're not going to get large swell or maybe even noticeable swell, again, because most of the fetch is in the north side pushing this direction. So let's talk even longer term, our La Nina. El Nino, all but gone now. La Nina starting to develop. Let's get into those details. So we like to monitor wind, speed, and direction on the equator, specifically from the date line east to about 135, 5 degrees north and south of the equator. Draw a little box here. Okay, actual wind speeds, this is from buoys on the ocean surface right there, not from models. Clearly, easterly trades in control of most of the equatorial Pacific, but in the area we call the Kelvin wave generation area, you notice there's almost no wind. Anomalies, differences from normal from this time of year. We're just looking at the arrows here. Pretty much a normal setup, though westerly anomalies over the Kelvin wave generation area. We monitor this area because it helps suggest what's going on with the Madden-Julian oscillation. When the MJO is in the active state, that helps fuel the jet stream in the southern hemisphere. A less direct correlation than the jet stream fueling that occurs in the Gulf of Alaska in winter months, but still nudges it along a little bit and helps give us some indication a couple weeks out of what's going to happen and will we have more storm development down south. So light westerly anomalies would suggest an active phase of the MJO, therefore fueling storm development a little bit. Another way to see what's been going on, and again, the Kelvin wave generation area, we're looking for the same thing, goes from about here to here on this chart. This is the whole planet on one chart, wrapping the whole way around. But it's this area here that we're really looking at. Yellows and oranges are westerly anomalies. Blues are easterly anomalies. Easterly anomalies suggest the inactive phase of the MJO. Yellows suggest the active phase. So the latter half of June, we went into what appears to be the inactive phase of the MJO. Now we're here into July, and there appears to be this weak kind of discontiguous active phase of the MJO trying to get going, but notice also there's equal parts of easterly anomalies, so whatever active phase it is exceedingly weak, and the forecast for the next week per the GFS model, this up at 4,500 feet, which is a reasonably good approximation of what's going on at the surface, suggest, if anything, and here's our Kelvin wave generation area right in here, that pretty much a mixed bag of both east and west anomalies, and none of them particularly strong, which suggests, and notice this, you could actually draw a line here and say this is the active phase of the MJO, and it's pulling out of the Kelvin wave generation area about now and moving into the East Pacific, so that won't do a whole lot of anything for the southern hemi in terms of amplifying storm production. Next, we take a look at precipitation anomalies. This per the statistic model, where yellows, in this case, suggest more sunlight reflectivity off the ocean surface. That suggests high pressure. That suggests the inactive phase of the MJO. But notice here that it's over such a tiny area. This is the current image that basically it's neither active nor inactive. And the forecast for the next 2 weeks can suggest a continuation of the same thing. The dynamic model suggests perhaps a building of the inactive phase of the MJO about a week out or so. Not super strong, but not non-existent either. Both models suggest nothing, at least from a precipitation standpoint, indicating no active MJO signal. Phase diagrams. This is another way to look at the MJO. Assume you're looking down on the North Pole of the North Pole of the Earth, and the active phase goes counterclockwise from the Indian Ocean over the maritime continent, which is, think Bali, that area, and then over the date line into the West Pacific, over into the East Pacific, over the Americas, into the Atlantic, and then over Africa and back into the Indian Ocean. The big dot suggests where the active phase is, which is kind of nowhere, and if you're inside, the further away from the circle here, the stronger the MJO is. This suggests basically no active MJO in occurrence per the ECMF model, and the GEFS, which is the GFS model ensemble version, suggests the same thing. So a very, very weak and diffuse active MJO signal. And finally, the trusty old CFS model, again up at 850 millibar level. This is about 4,000 feet. This chart is in reverse. That is, this is, past history down here. The forecast here, it goes out a couple of months. Yellows, of course, are the active phase of the MJO, westerly anomalies. One can associate with that. And here we'll just overlay MJO. You can see it, though, plain as day. Look at these westerly anomalies that started late June. And these are very weak westerly anomalies, are currently working their way. The Kelvin wave generation area is right about in the middle of the chart here. That's where the date line is. And then working their way off to the east. But here we'll put it on. You can see we're in the active phase of the MJO, pretty weak. And by the 18th or 20th of July, it's supposed to be gone. The dashed contours suggest the inactive phase, and it looks to be equally as weak as this active phase. And with easterly anomalies in the Kelvin wave area, very weak, and then another weak active phase beyond that. All these westerly anomalies forecasts are, for the most part, over the maritime continent or the East Indian Ocean. We can overlay the low-pass filter here, and this really tells you where El Nino is or how strong it is, or where, really, another way of saying it, where the highest probability for precipitation and inclement weather would be. And this suggests that this is our El Nino fading out by the end of August, and you can see the beginnings of La Nina setting up in the Indian Ocean here. So, typically during La Nina, most of the storm activity is over in the Indian Ocean. And from the reports that most of you already heard, yes, Indian Ocean is pumping, lots of surf there. Not a bad place to go take a trip. So what we had is the beginning of the summer, especially June, pulsed pretty well in the Pacific, lots of southern hemi swell, but you can see the transition starting to happen. Energy getting leached out of the Pacific, moving off to the west towards the Indian Ocean. That's where, if you're going to take a trip later in the summer, that would probably be the place to go. So the MJO pattern, not looking particularly strong. Let's go even longer term. In the MJO, you kind of gives you a 3 to 4 to 5 week window of what might be coming, and we're not seeing a whole lot. Whatever is going to happen favorably for us is happening right now, and that's not a whole lot. Kind of there's southern hemi swell, but it's pretty small, pretty weak. Now we had 3 good solid pulses of swell so far this summer, a total of 9 significant class swells, but they were all bunched on top of each other, 3 at a time, all on the same week, in the a couple feet overhead range, which was good. Hope you got a lot of that, because it just doesn't look like there's a whole lot more coming anytime soon. Long term, further out, La Nina, we see this is a subsurface temperature, West Pacific here, East Pacific here. You can see warm water building in the West Pacific. If it was El Nino, all the warm water would be here, but now what's happening, warm water that has been here for the past 2 years is retrograding, moving back into its normal position, let's say off the Philippines, that area. That would tend to increase tropical development over on this half of the Pacific and shut it down in the east. Differences from normal for this time of year, subsurface. Notice 1 degree above normal setting up in the West Pacific. There was a little shadow of a pocket here off of the Galapagos in Ecuador. 1 degree anomalies. That's all but gone now. 3 degrees below normal in the central, under the central Pacific, and upwelling to the surface here about south of Hawaii. This is pretty much classic La Nina. Notice there's no warm water pushing this way. For 2 years during El Nino, it was Kelvin wave after Kelvin wave, that is bubbles of warm water pushing this way due to westerly anomalies, westerly winds in the West Pacific, hitting Ecuador, making a warm pool here. Now we have a continuous river of cooler than normal water that will eventually break its way into the Galapagos area, upwell to the surface, cool things down, and set up the standard La Nina pattern. Another view here, same sort of thing, West Pacific, East Pacific, temperatures at depth, blues are below normal. You can see a continuous river, cooler than normal water, this working its way to the Galapagos. The previous chart didn't show that as much, and there was some warm water here. It's all but gone now. Here's the main upwelling. You can see it plain as day right there. What is that? 2 shades, so 1 to 2 degrees below normal, and that's classic, pretty typical La Nina. Upper ocean heat anomalies. This is the West Pacific. This is the East Pacific here. This was Kelvin waves moving from west to east in September of last year. Another very big one in November. One last little baby one February this year. And then you can just see the cool water regime setting up. Say goodbye to all this up here. It was a great run, very nice, fun to watch. Now we're into the polar opposite of that. Zoomed in, see surface temperature anomalies. Differences in normal in this time of year. As expected, cool water developing because of enhanced trades and just cool water subsurface along Peru, working their way up. The standard wind pattern is this way, right up the coast. And there you see cool water upwelling over the Galapagos, then tracking east, south of Hawaii. This is that big pool that we saw upwelling subsurface right there. What are those temperatures? Probably 1.5, maybe 2 degrees below normal, something like that. These blue pockets, clearly not an El Nino pattern. Here's the lingering El Nino warm water. It was a tiny little thread of blue running here, but notice it's building its width and pushing out the warm water a little bit at a time. Now, this warm water is what's responsible for the hurricanes that are occurring right now. And since trades aren't stronger than normal, and there's still hangover from El Nino, so that's helping spur tropical development. But as we get deeper into the summer and as La Nina gets more established, we would expect tropical activity in the East Pacific to shut down, and all the focus would turn to the west. Next up, the trend, sea surface temperature trend over the past 7 days. Blues suggest cooler than normal water, a very robust cooling pattern setting up here. La Nina, of course, responsible for this, and pulsing. It kind of comes and goes. We see this from week to week. It'll get real strong, and then a week or two it'll back off, and then it'll get strong again. And so it sort of breathes and pulses. We also look over here off Africa. Sometimes you get a mirror image, and sometimes this is an early indicator of what's going to happen in the Pacific, and it's been pretty well correlated this year so far. Cooler than normal, though in the actual tropics, let's say right up in here, it's getting warmer than normal, cooking off Florida in that area, supposedly. Also notice warmer trend here. This is PDO, related Pacific Decadal Oscillation. The temperature's a little bit cooler than normal, certainly cooler in Northern California as of today. Now that was the trend. Here is anomalies, differences, normal from this time of year, the backed off view. Clearly, the La Nina pool, very visible and building, but hangover from El Nino all over the place. Almost, we've talked about this before, the climatology we suspect is a little bit corrupted. It's hard to believe there's this much warm water unless what's happening here is the oceans are acting as a heat sink, absorbing heat, and so NOAA every 5 years has to update the climatology. They used to update it only once every 10 or 15 years, but they're down to every 5 years updating it because the oceans just are getting warmer and warmer. We're talking, fractions of a degree, but still, that's the difference between El Nino and La Nina, sometimes half a degree, so every tenth counts. And then the PDO cool pool and associated warm temperature southeast of it. Next up, correlation of the atmosphere with La Nina. As we saw here in January 2014, this is the Southern Oscillation Index, difference in pressure between Darwin, Australia, and Tahiti. The Southern Oscillation Index was falling steadily into October 2015, suggesting the development of El Nino. Negative numbers here, minus 10, minus 15, minus 20, suggest a strong El Nino, but notice the trend is now pushing upward. You can actually see the active phase of the MJO, inactive phase, but notice the active phase is getting, just like here, where we had this giant push of the active phase of the MJO to kick us into El Nino in the April timeframe. Now here we are in April, and well, it's actually later than that, but a big push of the inactive phase of the MJO ushering in La Nina. This is pretty standard 2-year run here. Actually, that's more than you could ask for to get 2 years out of it. Actual numbers from the Southern Oscillation Index, current past couple of days, minus 2. Today's value, minus 2.20. The 30-day running average, positive, moving into La Nina, 4.61. That is La Nina territory. The 90-day running average, negative, but you know what? That's going to be neutral, if not moving positive too. All this suggests a transition to La Nina. And of course, La Nina tends to not favor storm production in winter months in the Gulf of Alaska. And what happens is during La Nina years, you can still get very intense storms, but they are short in duration. They're not as large storms. There's not as many of them. And so the resulting swell is you get a day of swell and that's it, and you're out of there. You don't get these multiple days of swells and swell after swell. You get a swell, maybe one swell, and then you sit for a week or two and nothing happens. Another swell. It's much more sporadic, much less prolific. The ESPI index, which is much like the Southern Oscillation Index, only it measures the difference in actual precipitation versus surface pressure in these two areas. Current value is minus 0.9. That is La Nina territory. When it's positive, it suggests there's more precipitation than normal in the Pacific. So this is, again, another indicator of La Nina, though not particularly a strong one. And finally, the surface temperature forecast in the Nino 3.4 region. Okay, here was our El Nino, plus almost 3, was at 2.9 or 2.8 degrees above normal in the Nino 3.4 region, a very strong El Nino, and now the typical rebound, overcorrection, if you will, by the atmosphere. Forecast, right now temperatures are about neutral, but as we get into, September, we're supposed to get close to the bottom at about a minus 0.65, I'd say, and holding there steadily into December, and then slowly working your way up. This is a pretty consistent with what the consensus of a bunch of every other model that measures temperature forecast for the Nino 3.4 region. They're saying minus 0.7, maybe 0.8, which suggests that this would not be a very strong La Nina, especially considering how relatively strong, at least from a pure numbers standpoint, this El Nino was. You would expect a bigger and almost equal correction, but the models aren't suggesting that. So it's going to be interesting to see how this plays out. This suggests, perhaps, that the PDO, even a longer term cycle. So we talk about the MJO, which is like a 3-4 week cycle on and off. Then you talk about El Nino, which is a year or two on and off, or really 7 years on and off. And then you talk about the PDO, Pacific Decadal Oscillation, which is 15 to 25 years on or off. We've been in the off state, the negative phase of the PDO for 15 years. Since the last big of El Nino of 97, 98, we've kind of been in a hole. Yeah, there's been some moments, but storm production, swell production hasn't been stellar, to say the least. If we are moving into the, I'll call it the active or the plus phase of the PDO, which we won't know for about another year or two, that would help explain this rather weak response to this El Nino, and maybe suggest that we're working our way into a 15 to 25 year cycle of much better surf. That would be very good, especially for people that are just learning to surf and just getting their feet wet. They could be pros by the time it's all over, and then they could be like the old guys today that are griping about how the surf hasn't been as good as it was back in the good old days. So we'll see. Let's be real for a moment. Looking at the forecast charts, looking a week out is fraught with error. The models typically don't verify even a week out. So when you're talking 3 and 4 months or 3 or 4 years or 15 years out, it's all rampant speculation. Who knows? But it's kind of a fun game to play, and you watch these charts week after week after week. You actually find the models do a reasonably good job. They give you some heads up, and you can use this to manage your training routine, know what to expect, sort of keep your eye on thing, and know where to be and how to catch swells. The more information you have, the better of a surfer you will be, or at least you increase the odds of walking away getting good waves if you have the data in your back pocket. So, that said, small swell in the water, maybe another pulse midweek, maybe another small swell originating from under New Zealand late next weekend or so relative to California, and maybe late in the work week for Hawaii. Another pretty good system kind of targeting more chilly in that area. Certainly a lot of surf there. If you're making a trip down south, you're going to score that. But again, that's looking all, 5 days out on the charts, but it's a pretty good indication that something's on its way. Beyond that, yeah, we're in the active phase of the MJO. Not very strong, not a lot of enhancement for the jet stream for the southern hemi. Probably not a whole lot going to happen. That doesn't mean it won't, but just probably not a whole lot. And then the transition, of course, to La Nina. You would be best to set your sights lower for this coming winter. Sometimes the snow can be pretty good, though. The La Nina after El Nino, there's still a lot of condensation in the atmosphere, and you get cold air with La Nina. Last time we went into one of these situations after the 2009-2010 El Nino into La Nina, epic dump of snow in the Sierra. We're not saying that's going to happen this year, but something to look forward to. And then, of course, perhaps, maybe, just maybe, the transition to the active phase of the PDO for the next 20 plus years. Anyway, that's it for this week. Hope you enjoyed this. We'll do it again next week, same time, same channel. Thanks for watching.